So I have defined some new functions here. Directly like map create dynamic, map create static for a fixed number of buckets, and this is so that we can decide it dynamically. Okay. Then along with that, this function get size, which just simply returns the number of current entries in the map. I can have function to get the threshold of a map, which bucket size into load. Then we'll check uh, the number of entries should be less than or equal to the threshold, else we resize. Right. So we have this mention. This is get size, this mention, resize. Okay, and whenever we set, we add the bucket, right? We create a node, find bucket, snap key the hash bucket. I think I should get the bucket. I should also check. If not, and create. Also, I should try and find it hash map get. Hash map get. Uh, Hash map get node simply finds the node from a bucket, right? Setting, and then we get it. Hash map get. So I want to call. I want to use this function hash map get. I should not get node, right? So I want to use this function. I want to use this function within here. Hash map set, yes. So I go hash map find bucket. Okay, so wherever that is. So hash map set, right? So I want to I got the bucket and I have the hash map. So improvement check if the key exists, then override that one. So I have the bucket, right? We check the bucket. Then I have to go underscore get node map. Okay, I didn't need the map this time. Okay, so this section, why do I even take a map? Pass in the bucket. We don't need the map for this. Let me get rid of the map. We've been using the map. So maybe we'll just keep it how it is. Bucket node. Hmm. So hash map underscore get node map hash the bucket and the key. Hash map underscore get underscore node. Passing the map, it should check the map. Also, it should check the bucket. Bucket not be okay. Then we have so the set function. I pass in the map, pass in the hash. Do you have a hash? Right? Yep. Hash. Then I pass in the bucket. And I pass in the key. Key. Then check that our check our switch hours. Okay. So if hash is less than zero, then I can create this net is less than zero, then I should create else you non existing node was found. So we create a missing node else if an existing node is found. So so check bucket pointer value changes depending if we find the given existing node is found. Then we simply get its pointer override the value. we get the pointer and overwrite its value. So the array is to get something right. Pass in the array and the int, and it will just return me awesome the bucket and ours. Okay, check mode should not be null. Okay, yeah, I don't think it will be null. Okay, no, node should can node be null. No, node cannot be null. Key can be. So I notate check my on that. This is the original one. Okay, so stick check if the key already exists, then override that. Override that value. Else add a new node. Right. Create the nodes. If I is less than 0, c minus 1. Do this. Else node exists. Just go node hash data. Just go hash data equals data. So, so we won't increase the number of entries if we found the node. Okay, so hash set 0. Okay, so set. So I have to check first. Okay, first I have to check if everything works right. First step, check if everything it should be. Yeah. Ah, check 312. That's not dot C. Check. Try that again. If it is giving error, use could not check. Okay. So clean this. We make so nothing is disturbed by that. All the test case. Okay, right. Great. So nothing has gone bad. Testing. Retrieve. So now I want to test gets it, test override. New value forward. So we are just basically checking the address. That yes, for experience we are passing in the address, so we will be storing the address. Okay, so let's just go. Basically, just do this. Expect force, yes, expect force. Expect force. Then we return. No, this is important. Just reverse. So and the entries should not change, right? That's true. Right. C close hash mark. It's science. That we will should be three. No value from map size. This right. So especially when I want to traverse this threshold just over it. After it set, test over make okay. Should get test failed. Failed. Oh, test leak. Yeah. Okay. I will update test leak. Delete it. Should be expect force. should get just the string hash map and yeah, you make all test cases should pass. Right, right. Reverse. We this test data reverse. Key is okay, so we are only printing the key. Reverse. Right. So reverse. Hash map. Reverse. Is this function? No. It should be at the top. It reverse. Just okay. It is just printing the key. Print the value. It's the same. Yeah. Huh. No touch value. No value. Bro, you kidding me? Oh, data has data. Hmm. Yeah, value. Okay, so it does also print this data, so the value for that. Okay, great. If the key already exists, then we simply right. So now I have to make it so it is resizable. Grid size, entries don't change. On delete, I want to um, entries where is not delete. See, yeah, update the update the size. So we'll go with map entries minus test it. Test delete. Let's test delete. So it should be equals to hash get size round size size deletion. Here I want to copy this whole line. Should be two. It should be one. Finally, this should be three. rebuild the test. Huh, long size application 116. Okay, sorry. It should be 2. My bad. It should be 1. This should be 0. We have deleted, so it should already decrement, right? So it is great. Now I have to focus on what? Resizing the map. I have to focus on resizing the map. Grid size 55 here, x. We want to double check that we have the value in the new. Okay, revision 1. So first check if the size has first check if the size has the hash function has not changed, right? So the hash function has not changed, so I can simply rehash with the new size. Just create a handy function. Static hash map rehash. Map. Okay, I have the map and what else? What else? For rehashing, I'm thinking about it. But for now, let's check this. Let's check the size has exceeded the threshold. Let's check hash map size. Okay, if it is less than or equal to less than or equal to hash map. Sorry, this is get size map should be less than or equal to get threshold. If this is then stuff info inside the map. I'll go to check debug. If this condition is failed. Right. So can I start and resizing? So I would have to add so I would have to add okay I wanna get first get the pointer to the existing buckets. This is an internal function. So using the with it here hash mark set, so it already checks, so I don't have to check it unless I use it elsewhere. Okay. So first I will get the pointer to the existing bucket. So all buckets equals now hash buckets it is the first hash map of this array buckets. Then I will say set buckets equals none. Now allocate new memory to the hash map. To for map. So uh, buckets in create to the element size and initialize. So the element size is size of the array pointers that is storing the array. The initial max is 2 into max bucket size, right? Suppose to that bucket size, doubling the so doubling the size. Then we check okay. With this condition, conditional fit happens should be this, and I set an initial bucket of 2 into non bucket size. Then I want to rehash the values, right? Okay, so I have the hash. After this, I update the bucket size, bucket size equals to. Then I have to rehash the values. the hash map get, hash map get finds the bucket, takes the hash, it so finding hash map is the get to the bucket. This is hash map. I could have used a check macro. So hash map to find bucket now. Here and hash. Okay, so let's see hash map find bucket. So yeah, this is the new bucket size. Okay, that's the values. So I'll take hash map set. Okay, so I would have to find the buckets, right? Set find buckets. Buckets. Hash map. Okay, so it's uses internally hash map find buckets. Being machine the value. Okay, so I can just use. So I'm basically creating new. No, I'm not creating a new map. And hmm, here, you see, I have the hash. Right? I have the hash. And I just get the bucket and I create the buckets depending on. I don't have to create a new hash, but I do have to do this. Check with this. Hash will be fine. Yeah. Change the value. Change the values. Change the values from previous buckets to new. So I'll start a loop. So we'll go with So the size I could see and P and buckets plus looping to the buckets. Right. Then the pointer to the bucket. The array bucket equals the get buckets if the bucket exists. Exists. The bucket exists. Then I can just add a node, right? Just add a node and I could free a node just after that. Right? The bucket exists. Plus individual bucket. You can then okay. To add this to the bucket. This node to the bucket. Okay. Yeah, node into the bucket, right? So how can I add this node now? I want to hash map find bucket. So we generate a hash, but I already have a hash, and the hash is not going to change. Now find the bucket, and so I feel like I should really use hash map node set I went through set, but it will generate a hash. So the hash has not changed. That's what I'm saying. That the hash has not changed. So so we'll go with just oh, I can add this node into the bucket, right? So I'll add this node into the bucket. So I will have to first okay, just quickly. Okay, I actually hash, but I have to fetch the node. So get the node from bucket. Map or it is hash map. It is hash map node. Hash map node. D get bucket. Okay, I can then keep it here and then continue later. Okay, so because I have this, I get the node from the bucket. Dear account. Right. This is a valid function. Okay. So I get this dear account. I check the bucket and basically I get the bucket from the dear end and then okay, then we get we do this whole thing. Hmm. Check the bucket this. Let me make some space. Go bucket and hash. But where do I get the hash from? Hash. Get the hash from node. Get the hash from the node. Right. Hash from the node. This pointer. Right. Get this and okay, so I have this DRA, DRA, okay, so it hash, then I'll size, bucket this, if not bucket, if not bucket, then we create the bucket and add map set, uh, add this bucket here, right, we add the node, I take it from the bucket, right, then I find, then I'm rehashing the value, rehashing the value from previous bucket, it's in the bucket now, then bucket, yeah, new bucket, okay, I'm finding, now we check if that bucket exists, check if that bucket exists, bucket exists in the app. If not, if the bucket does not create a the bucket does not exist, let's call it new bucket. New bucket get get and new bucket. Then within the new bucket, I want to. Alright, then bucket and I'm out of this loop. Allocate memory from that. So direct clear this one. Direct set, direct get, direct new, push pop, clear, deallocate memory from the. So if array of contents, free array of contents, and then free array. Okay. So this contents, right? This contents I have been adding within that contents. Okay. Yeah. So I can just simply DLA destroy. Yeah. Simply DLA destroy. Destroy. Okay. It won't actually like it deallocates, right? What does this function do? It creates, we allocate memory to the contents, and here's the place where we store our memories, right? Okay, so that is the place where we store our memories. So it just simply deallocates, but when we have to add, like when we push an element, adding it in the content, but the memory for that element has been allocated somewhere else. So this is fine. Okay. Now it then after I'm done with to destroy this. Say, destroy this bucket. Okay. So as this function we hold buckets, then we are going within each bucket. Within each bucket, I'm fetching the node, right? Then I'm checking, like we can say, already contains the hash values, right? So I have this node, I have this pointer, new bucket. Then I'm trying to get that bucket from the new bucket. If there is no such bucket, then we create a new bucket and set it at this place, and finally we add this, right? And when we are done, we deallocate memory to this, and at the end, I want to deallocate memory from the old buckets. Array destroy old buckets. Set bucket equals null. Okay. So this is mentioned that rehashes. Okay. So we have this rehasher, which is the value. So I can call this function hashmap hashmap underscore hashmap underscore rehash. Right? So rehash map and the new buckets. The map buckets. I should set it null here. Okay. and so bool static bool resize. Bool I don't have a definition for it, right? That is the only definition. Okay. Right. Wait. So I have this. Okay, then rehash static inline. Just too big to be inline. Just retrieve hash underscore hash map underscore rehash. Find the bucket. We create the bucket if it exists. If it exists, then it's okay. If it does not exist, then we bucket. Destroy. Then I'm to destroy all buckets. Okay, so what is the condition? Hash map set, right? So I will check uh, resize. I should not check this value here, right? Just perform the check straight up, right? Yeah, this is better. Yes, and I won't have to worry about entries anymore, right? Because it's rehashes. It just automatically, right? I have updated the number of. Yeah, this is great. This is great. Check now. Also check all the function resize like okay. See, hash map get size should be less than or equal to get threshold. If it is equals to threshold, right, then I have get the when the number of entries when the number of entries are say 12. So this is okay, existing number of entries. Yeah, this should be less exceeded the threshold. So changed less than equal to less than because if say the threshold is 12, threshold is 12, and the size is also 12. Hey, 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 hey. So check debug. You want this condition. Okay, so if this condition is false, it will. Okay, so if this condition is false, it will go here. So I want this condition. So I want this condition to be true. All right. So I said, if is greater or equals to, right? So when this condition is, I want this condition to be, no. See, if this condition is true, right? If this condition is true, then simple code execution happens. And if this condition is false, we are asserting, we are saying that map should be greater than equal to threshold. If it is not greater than equal to threshold, if it is not, if the size is not greater than, okay, wait. Just, okay. So I say that we want to check that hashmap get size hold up, equals to say that get my size is equals to this condition is, if this condition is true, right, then happens. If this condition is true, we go here. Hold up just a second. Okay. So yeah, okay, so if this condition is true, then code happens, right? So I want this condition to be true. Okay, yeah. So if this condition is true, okay, if the size is equal, changing this to this, because the shear channel size is also 12, because the resize to happen only when, yeah, I want the resize to happen only, only when, only when our assertion that map size is greater than greater than or greater than or equal to the threshold. In any other case, I don't want to resize. There we go. So size. If this condition is true, then the following code runs, else it won't. And rehashing the buckets, right? Okay. So I'm just adding this node and destroy here, then destroy. And I think the destroy clears, right? The array clear, yeah, it used to do this. I don't want that. Great. So I will automatically resize. I don't have to do anything about it. Static void resize. I can just call the function for resizing and it will automatically check check the conditions for resizing. hash map, resize, then go map. Okay, so it checks to check if the already exists, then overwrite respective value. So doing this shouldn't affect any other tests, so I can try that. So I have attachment persists to 70. Check check mem new bucket. Why is this? Oh, error. Right. Okay. Yeah. Okay. Hash map rehash should bool this. Okay. So I do this and this value is this. Bool r equals so to return true here, else I return false. Okay. Check the conditions and then I'll check and oh, it's 20%. Huh. Check debug. Okay. So hash map. Okay. So I can go check. I don't want to resize. That is, it will jump error label. It will jump to error label. Now allocate new memory to the hash map. Map just bucket create, doubling the size. Now to rehash. Check our okay. So this value is true, then the following code will execute, else it will return. Right. So if this value is true, these are rehashing should be true. If it is false, then I want to make some changes. Okay, so I want like if this value okay, so I want the opposite, right? So if it is true, I say that R check. So I say so when it will go through the loop, it will return me true. That means it has successfully and it will continue executing. But I want to say that it will continue executing. But I want the opposite. So I'll go R equals true, which will be true, 1, and opposite of 1 is 0, and opposite of 0 is 1. So it will say 1. Oh, no, 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 no. Okay, so I can put a false condition here. Generally, I say that this should be false. I say that R is false, and when it is actually false, it will continue. Equals false. If this is false, if this is true, debug, then I should also, and this should be a bool. Hash map precise, check num, and I return true, return false, dog at the end. Hash map precise, but you know, yeah, I think I will continue later.